Hi everyone, I am Vandana from 3rd Sem BCA and my topic is Windows architecture. Architecture is a layered system of modules. The main layers are HAL, kernel and the executive which run in protected mode. A collection of subsystems and services run in the user mode. There are two types of user subsystems. First one is environmental subsystem and protection subsystem. Environmental subsystem is it simulates different operating system. Protection subsystem provides security from function. The main advantage of this type of architecture is interaction between modules are kept simple. First layer is hardware abstraction layer. It is a layer between the physical hardware of the computer and the rest of operating system. It was designed to hide difference in hardware and therefore provide a consistent platform on which the kernel is run. Hardware abstraction layer includes hardware-specific code that controls input-output interfaces, interrupt controllers and multiple processors. All hardware abstraction layer implementation depend on the kernel or the executive. That is, kernel and abstraction layer are designed to work together. Second layer is kernel. Kernel has four main responsibilities. First one is thread scheduling. Second one is thread priorities. And third one is synchronization. And fourth one is exception and handling. Kernel is object oriented. The kernel performs its job by using a set of kernel objects whose attributes store the kernel data and whose methods perform kernel activities. First responsibility is threads and scheduling. Windows uses processes and threads for executable code. Each processor has one or more threads and each threads has its own scheduling, state, priority and CPU usage information. There are 6 possible thread states: ready state, standby state, running state, waiting state, transition state and terminated state. Ready state is thread is waiting to run. Standby state is the highest priority thread is moved to standby state and it is scheduled as the next thread for execution. Running state. Thread is executing on a processor. When a thread is executing on a processor, a thread is in the running state till it is preempted or it's terminated or its time slice elapses. Waiting state. When it is waiting for dispatcher object to be signaled. Transition state. When a thread waits for necessary resources for execution. Terminated state. When a thread finishes execution. Second responsibility is thread priorities. The dispatcher uses a 32 level priority scheme to determine the order of thread execution. Priorities are divided into two classes, variable class and real-time classes. Variable class contains threads having priorities from 0 to 15. Real-time class contains threads having priorities from 16 and 32. The dispatcher maintains a queue for every scheduling priority and traverses the set of queues from highest to lowest until it finds a thread which is ready to run. Third responsibility is synchronization. Key operating system Data structures are managed as objects that provide facilities for allocation and security. Dispatcher object controls dispatching and synchronization in the system. Example: event object records an event occurrence. Mutex provides deadlock-free mutual exclusion. Timer object is used to keep track of time and to signal timeouts when operations take long time. Fourth responsibility is exception and handling. The kernel dispatcher provides mechanism for handling exceptions and interrupts generated by hardware or software. Windows define several platform independent exceptions such as memory access violation, integer overflow, integer divided by 0, page read error, access violation, etc. Simple exceptions are handled by trap handler in the kernel dispatcher. Complex exception handling is performed by kernel exception dispatcher, which creates an exceptions record containing the reasons for the exception and finds an exception handler to deal with it. Exception in kernel mode and user mode are handled differently. In kernel and user mode, exceptions are handled differently. And third layer is executive. The Windows executive provides a set of services that are used by environment subsystem. The service provided are Object Manager, Virtual Memory Manager, Process Manager, Local Procedure Call Facility, Input-Output Manager, Cache Manager, Plug and Play and Power Manager, Registry, and the last one is booting. Objects are entities that are generic set of interfaces manipulated by user mode programs used to manage kernel mode entities. Objects are instance of object types. And second one is virtual memory manager. It is that executive component that manages the virtual address space, physical memory allocation, and the paging. The virtual machine manager in Windows uses a page-based management scheme with a page size of 4 KB on Intel architecture 32 compatible process and 84 KB and 8 KB on IA64 compatible processors. Each process on Intel architecture 32 processor has a 4 GB virtual address space. The upper 2 GB are used by Windows in kernel mode to access the operating system, code and data structures. The lower 2 GB are specific to each process and are accessible by both user and kernel mode threads. Third one is Process Manager. Process Manager provides service for creating, deleting and using threads and process threads and jobs. Issues such as parent or child relationship or process hierarchies are left to the particular environmental subsystem that owns the process. The Process Manager is not involved in scheduling for processes. And fourth one is Local Procedure and Call Facility. Fifth one is Input-Output Manager. Input-Output Manager is responsible for file systems, device drivers and network drivers. It keeps track of which device drivers, filter drivers, and file system are loaded. It manages the buffers for input-output request. It works with the virtual machine manager to provide memory, mapped file, input-output, and controls the Windows Cache Manager, which handles the caching for the entire input-output system. Sixth one is Cache Manager. In earlier operating system, caching was done by the file system. Windows provides a centralized caching facility. The caching manager works with virtual manager to provide cache service to all components controlled by the input-output manager. The size of cache changes dynamically according to how much free memory is available in the system. The upper 2 GB of process address space is used by operating system. The virtual manager allocates up to 1/2 of this space to the system cache. And seventh one is Plug and Play and Power Manager. Plug and Play Manager is used to recognize and adapt to changes in the hardware configuration. When new devices are added, for example PCI or USB, the Plug and Play Manager loads the appropriate driver and also keeps track of resources used by each device. The Power Manager also controls energy used by the CPU and device. Drivers for device not being used are told to shut off device. CPU are run at lower clock rate and or lower energy state. System can be put in standby mode with only memory on. And eighth one is registry. Windows keeps its configuration information in an internal database called registry. A registry database is called a hive. Separate hives are maintained for system information, default user preference, software installation, and security. Installing third-party application can cause damage to the system hive. Hence, Windows maintains a component called System Restore, which periodically saves hives as well as other software states like driver executables and configuration files so that the system can be restored. And the last one is booting. The booting begins when the hardware powers on and the BIOS begins executing from ROM. The BIOS identifies the system device to be booted and loads and executes the bootstrap loader from the disk. The loader loads the NT-loader from the root directory of the system device. NT-loader determines the boot device that contains the operating system. And my topic come to an end. Thank you everyone.